Alright, so does this make sense? I looked up the magnetic vortex model, which is basically the ring of magnets, all the same polarity, with a magnet, let's say on a ball bearing on a table. When you hover it over it, it spins. But I do realize that if everything is perpendicular, like if you were to rest that pack of tape on like a 1-inch block of wood on either side, so it's 1 inch off the table, and you were to put like even a little divot in the table in the direct center of that roll of packing tape with a ball bearing with a magnet glued to it, it would eventually stop spinning because you need to have that wobble. Okay, the Earth has a tilt. 23.4 degrees. Now, 90 degrees minus 23.4 degrees is 66.6 degrees, and I find that to be significant. Now, if you can show me how to glue a magnet onto a ball bearing at a 23.4 degree tilt, you know, like, I think what's going to happen is no matter what, the magnet's going to want to be like perpendicular with the field from that roll of packing tape. So the only way I can see how to do it is like at the end of an axle. If you have the end of an axle, you should be able to put a little, like cut it on an angle and have it off center. And if that magnet is off center, let's say at 23.4 degrees at the end of your axle, inside of heaven, and you are able to cause rotation, that wobble, I think, is needed for perpetual motion. Now I also see that you need to, and like there's a lot of, like the video I'm going to link to this video, it shows that there's like, you know, magnet, battery, copper thing goes on top. Wow, there you go. It spins like a motherfucker. So there needs to be that charge. Now that charge from the battery, is it like, does it want the volts from it, or is it the amperage? I think it's the volts. Now if it's the volts, then I already have an idea about how to get voltage sources in series using, again, magnet insulator, coil, antenna, where the coil would be whatever, like sprayed with whatever the metal is needed for hot water tanks, because that, like, you know, heats up fast, it's passing electrons fast. So if you can get 3 volts out of that and put a bunch of voltage sources in series, you should be able to get your 120, 240 volts. Now let's think about what we can charge on this model, because I'm also thinking about Hall effect sensors. Now, Hall effect sensors are like a switch. I know Gerald Moore uses a spark gap, and the spark gap is obviously a gap that gets bridged. And if you have a gap that gets bridged, it's like a revolving door. It's like a revolving door that's spinning, and you can only get in at certain times and get out at certain times. So there's, you know, your high and your low. When your north is near the Hall sensor, it's the strongest. When it goes away, let's say it's the weakest. And your switch is opening, and closing. But if you were to rotate it fast enough, it would just be like on and on. So like if you had an LED like hooked up to a Hall effect sensor in some kind of like very simple circuit, and you had a perpetual motion machine running, that light would blink. But if you were to make it run fast enough, again, it would blink faster. If you were to make it run super fast, it should just stay on. That's what I'm saying. It's like alternating current that's almost like direct current. So, hear me out here. Now, the placement of the Hall effect sensors you can find out after the solenoids have been wound in the proper windings with, you know, the counterclockwise and clockwise, whatever's number of windings, yada yada yada. That's where you place your sensors. Now, maybe that gate is needed to act like the spark gap. So, like, let's just say this. If I had to insert a charge from, let's say, a battery. Let's say if I had, whatever. I had a piece of wire that had 120 volts coming out of it. Doesn't matter how I got it. Okay. Where would I place that wire around the magnets in heaven to induce that rotation? Or would I want to take that wire and connect it to the wires coming out the solenoids? So the charge goes into the solenoids. That would turn the magnets around the solenoids, which would turn the wheel, which would turn the axle, which would turn the thing in heaven. And once that's turning, would it slowly accelerate until equilibrium is reached? But then how would you extract the energy? You would have to extract the energy by these Hall effect sensors. And if you had the Hall sensors in between the solenoids, that would open and close circuit. Should be enough to power stuff? I just can't think. You can't put a wire contact on the axle itself because it is in rotation. Now the only way I can think of doing that is if you were, I don't know if there's like some kind of ball bearing that you can put a charge to that charges if the, you know what I'm saying, like if I had like a, let's just say if I loosely wrapped copper wire around let's say I have a wooden axle and I take copper sheet metal, wrap it around the axle, whatever, epoxy it or whatever, and then I loosely wrapped copper on the far end on the outside of the box to that axle. Now wouldn't that charge the whole copper, which would then go into heaven where the magnet is on a tilt inside the ring at the right sweet spot? Would that be the solution somehow to get that charged magnet? But it's around magnets, not solenoids, or not around copper. Materials. What if the rings of heaven were made of copper? In the last video I watched, he used copper sheeting. He didn't use solenoids. He didn't use copper windings. So if the rings of heaven were copper, but had magnets on them, and you introduced a charge from a 120 volt source to the ring itself where the magnets are stationary, and you put, let's just say, a wooden shaft or whatever, PVC or whatever fuck 3D printing shaft with a magnet on the end on a tilt, since the device can't move because it's stationary, it wants to move something, it's going to act on the lone magnet in heaven on the end of the axle. Would that turn the axle? Where is the charge? Maybe it has to be in both places. Maybe I need a charge on the solenoids and I need a charge on the ring in heaven. See where I'm going with this? Any of you people that are like, you know, little hobbyists with your shop and your electro gizmo gadgets. I know I'm being very professionalisms here, but magnetic vortex seems to work the best if there is an induced charge, and Kevin doesn't believe in batteries. Kevin thinks batteries are a fucking waste of time and money, okay? Where does the lithium come from? The lithium comes from Afghanistan. What just happened in Afghanistan? Okay. Now Tesla wants to make Tesla roofs or whatever, solar roofs, and then you're going to have a power plant of what, lithium ion, really expensive batteries that don't last forever, that basically we rape the earth to get these minerals to do what? To sell it to the goy of North America? Like, come on, guys. What needs to be what material? What needs to be charged properly? You have a rotor and a stator, and there's different elements of my model. I'm like so close, I can almost taste it. I mean, to me it makes more sense to have the rings in heaven out, like basically copper with magnets glued to it, where there's a charge on the copper itself coming from the outside voltage sources, which I've talked about before. Maybe that would create the magnetic vortex only if that magnet wasn't flush. Maybe it has to be flush, but maybe it's on a tilt. Maybe every axle is on a 23.4 degree tilt. If the magnet was on a tilt, it wouldn't be super balanced, but would that wobble at those speeds be detrimental to the construction of it? I don't know. Does it have to be flat? Maybe there's no wobble? Where does that earth tilt come into play here? I know 45 degrees is important because that's where the equatorial line lines up with Orion's belt and all the way through Cassiopeia, the main W, is at like literally exactly 45 degrees. And at 23.4 degrees, way over in the, I want to say, Arcturian constellation lines up with Phoenix at exactly 23.4 degrees from the equatorial line. I have videos on this. 23.4 and 45 are very important. Since we're using axles on the vertices of the cube, there's my 45, I need to introduce 23.4 degree tilt. I think the only place to introduce that tilt where it wouldn't really drastically matter with the overall rotation. Now, come on, it's on the epicenter of the axle turning. It's not like the wheel turning. The wheel's going to be balanced as shit. If the magnet at the end of the tip of the axle is 23.4 off, I don't think that would be detrimental to like breaking the construction of that wheel based on the RPMs it's spinning at. But you need to induce a charge. The charge needs to be volts, I think. And the volts need to come from magnet, insulator, coil, antenna, a whole bunch of them in series, and some kind of snowflake configuration, just like Frankenstein. 120, 120. So you have the choice of having many 120 circuits or some 120 circuits and some 240 circuits. And gotta get that fucking wheel spinning. So or do you have a slip wire on a copper axle with a magnet? No, because he had a magnet. He had a charged magnet. A charged magnet. So what does that mean? Okay, what about this? What if all this... forget the copper in the ring of heaven. What if the ring of heaven is made of whatever, but my ring magnets that I have in there, all 32 of them, have to be connected, meaning they're going to be touching. So you're going to have 8 magnets touching each other side by side, and then you're going to have a bearing, and then 8 magnets bearing, 8 magnets bearing, 8 magnets bearing. You're going to have to, I guess, use little jumpers over the bearings, unless the bearings are made of metal, and if the magnets are touching the bearings and the bearings are touching the next magnet, maybe they're all like connected. And then if you were to take your 120 volt charge and then, you know, pin it to the metal iron bearing magnet construction, maybe that's the charge on the magnet, and the copper will be, let's say, a copper lined axle with a magnet at the end on a 23.4 degree tilt. Is that more like the video I just saw? Man, it's coming on so fast. Like, I'm trying to put it all together. And I'm talking to myself, and I need buddies. I need to go back to Ottawa, I think. I need to get back there. And talk to my buddies about all this. We need to start brainstorming, because I'm getting frustrated. And it's go, 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 not slow, slow, slow. So... yeah, okay, I make mistakes. This is the whole point of it. Okay, you gotta make mistakes. You gotta beat up your own theories. If you don't beat up your own theories, someone else will. And if you make fun of yourself, you won't get beat up. You know what I'm saying? I like making fun of myself for how retarded I am, because really, I wouldn't like it if anyone else did. So I'd rather amuse you than be a magnet for your hate. But anyway. I really should try harder. Maybe read. I don't like reading. Maybe there's people out there that like reading. I hope you feel like I'm getting somewhere with all this, you know? Like, I hope I'm just not wasting everyone's time. But, like, literally. It's very interesting, Mr. Bond. Magnets need charge. Copper around magnet spins. Copper inside magnet ring that is charged. Will that rotate copper pole with magnet on end? I don't know. Gotta reverse engineer things. Things don't work the way they work, that everyone knows the way they work. In this application, you gotta think upside down, backwards, and flipped. I don't know if there's anyone better at doing that than me, but I toot my own horn, but I mean, it's just like, you gotta go full retard. And I don't think anyone's prepared to go full retard because they don't like being wrong. Everyone likes to sound smart. And be like, you know, the debunkness, the proof, the reason why, blah. Yeah. They're all just points of view, guy. They're all theories, they're ideas, they're just ramblings of people on the internet mostly. But I mean, I'm trying to get to a point, the top of the pyramid. Sharpen the shit out of that. Maybe put my cigarette butt out of it. But whatever. Cheers.